Welcome back to another M&S tutoring video, and today we're going to be learning about the different interior and exterior angles of a polygon. Well, first of all, we're going to start off by defining what a polygon really is. A polygon is basically any closed figure made up of different line segments. Basically, my definition of a polygon is basically any shape with any amount of sides, and where the exterior angles and the interior angles have a relationship to both the triangles inside and angles outside the polygon. First of all, let's begin with the exterior angles of a polygon. The exterior angles of a polygon has a very simple rule to follow. With any polygon, you will find that all the exterior angles, so in this case the polygon I used was a triangle, you'll find that all the exterior angles, which in this case is exterior angle A, B, and C, what you'll find is when you add all of the exterior angles, you will get 360 degrees. This is a very simple rule to follow when looking at the exterior angles of polygon, because you don't have to look at how many sides a polygon has, how many triangles are within it. You just have to look at the fact that all exterior angles add up to 360. This rule can be really helpful because if you, say for example, only have angle A given to you and angle C given to you. Say for example you had angle A, you said that angle A was 90 degrees, right? And angle B was also 90 degrees. Sorry, angle C was also 90 degrees, right? You could, as a matter of fact, solve for angle B because of the exterior angles of a polygon rule. You can quite simply say that angle B is equal to 360 degrees minus 90 degrees minus 90 degrees. Sorry if that looks like an equal to sign there. I meant to do a subtracting sign. So 360 degrees minus 90 degrees minus 90 degrees. So this angle relationship is really helpful if you, say for example, only have two angles instead of all three, and you could use this angle relationship to solve for the third angle. Now moving on to the interior angles of a polygon. Now with the interior angles of a polygon, it gets kind of tricky because you have to look at both how many sides the polygon has, or you have to look at how many triangles are within the polygon itself. So say for example you have a simple triangle. Now we all know that a triangle is a polygon, and all the angles inside a triangle, let's say angle A, angle B, and angle C, equal to 180 degrees, right? All the interior angles equal to 180 degrees. But how do we know that, say for example in something like a trapezoid, that all of the angles interior equal to 360 degrees? Well, how do we know that? Well, we know that because of how many triangles are formed within the polygon itself. Say in this triangle, you can form two different triangles. You can form triangle 1 over here, and you can form triangle 2 over here, right? I'll outline the first one in blue, which is triangle 1, and you can form triangle 2 in this one, right? So a four-sided polygon, or trapezoid, can form two triangles, meaning two triangles inside, meaning 180 degrees plus 180 degrees is equal to, as a matter of fact, 360 degrees. And now we know where that 360 degrees of a four-sided polygon came from. It wasn't just pulled out of the blue. It came from how many triangles were inside the polygon itself. Now, let's try and find an algebraic relationship that relates the number of triangles to the number of sides a polygon has. So it makes it a lot more simple for us if we had something, let's say a decagon, or maybe even an octagon. Say for example, we have a three-sided figure. So with a three-sided figure, we know that there is one triangle formed, right? So let's make a table here. We can say number of triangles, right? And we can say the number the number of triangles and the number of sides, right? So in a triangle, of course, in one triangle, there's one triangle, but this also has three sides. Now let's look at something like a four-sided shape, something like a square, right? If we have a square, there is, as a matter of fact, two triangles inside, right? We have triangle 1 and we have triangle number 2, right? So moving on to a four-sided figure, we have four sides and we have two triangles being formed. So now some of you may begin to see a pattern here. We can see that the number of sides minus 2 is how many triangles are being formed. Well, just to prove that, let's look at a pentagon. A pentagon has 5 sides, of course, and let's see how many triangles are in a pentagon. Well, a pentagon, it's not really easy to tell how many triangles there are because there's so many more vertices and so many more sides. So let's pick a vertex, let's say the bottom left vertex of this pentagon, and we'll try and branch out to the different vertices to form as many triangles as we can. So from the bottom left vertex, let's call it vertex A, and we'll branch out to the top vertex. And then we can branch out to this vertex, right? Now that we've branched out to the most amount of vertices we can, trying to form the most amount of triangles, we can quite easily say that there is one triangle, two triangles, and three triangles being formed inside a pentagon, which is a 5-sided shape. So we can write that a number of sides, 5, and there is 3 triangles being formed, right? So now that we can confirm this pattern being true, we can create an algebraic relationship between the interior angles of a polygon given the number of sides, right? Since the interior angle sum is always just 180 degrees times the number of triangles, if we have a formula for a number of triangles in relation to the side, we can have an algebraic relation dependent on the number of sides. So this is basically the formula for interior angles. Interior angles of any polygon, right? Now, what is the relationship for the number of triangles? Well, as we saw in our table above, we knew that the number of triangles is just the number of sides. So the sides minus 2. As you can see, the number of sides was 3 over here. And of course, 3 minus 2 is equal to 1. 4 minus 2 is equal to 2. And 5 minus 2 is equal to 3, right? So sides minus 2 is basically just the number of triangles, right? Now that we have this, we can plug in the number of triangles instead for the sides, and we can say that the interior angles of a polygon is equal to 180 degrees multiplied by the number of triangles, which can also be written as sides, the amount of sides of the polygon, minus 2. And here we have the algebraic relation between the interior angles of a polygon. So thanks for watching, guys. I hope you learned something new. Please feel free to subscribe, and if you have any comments or concerns, please leave it down in the comments below. Thanks for watching, guys.